Welcome. It's September, so we're nearly at the autumnal equinox. So it's time to review the status of solar cycle 25 for August of 2021. A quick summary of what's going on. It was a relatively quiet month, although we did have lots of small sunspot regions. There was one notable one, that's active region 2860, shown here on the far right of the picture. We had 55 flares greater than or equal to C1, and most of those came from active region 2860. We had 50 CMEs. We had 2 geomagnetic storms, both of which were relatively weak, G1 events. And sorry, there's still no service from Helio Viewer. I'm not sure what's going on there, but it does mean I can't show you any of those spectacular movies that it produces. First, let's deal with the sunspot number. This is from the Solar Influences Data Center in Belgium. This shows the sunspot number over the last 30 days in red. The gray is the uncertainty on that number. And you can see that we had at least 3 days in the month where there were 0 sunspot numbers. Some people seem to think that's important. I don't particularly. The big spike we have towards the end of the month was from active region 2860. Here we have the sunspot number for the last 13 years. So on the left-hand side of this is solar cycle 24. The yellow spikes here are the daily values. The blue are the monthly averaged sunspot number. And the red is what's called the smooth sunspot number, which is where we take the monthly values and average them over a 13-month period. Right of the red dashed line is solar cycle 25. Solar minimum was in December of 2019. So that's solar cycle 25 rising. And you can see there are 2 models. There's the CM model, which is this dash curve, and there's the SC model, which is this dashed and dot curve here. Now it seems at the moment that solar cycle 25 is following the SC model. How does this compare with the beginning of solar cycle 24? I'll override the equivalent time on solar cycle 24, and you can see that solar cycle 25 is outperforming solar cycle 24 by about 25% or so. As the maximum of solar cycle 24 was 116, if that trend continues, it would put solar cycle 25 at about 150. Now that is below average. The average is about 170, but it certainly does mean there will be no grand solar minimum that people keep on going on about. Note how the activity builds. It's in a series of bursts. I've indicated the bursts for the beginning of solar cycle 24 here with these black arrows, and you can see they're almost uniformly spaced, varying from 6 to 9 months apart. Each burst being slightly larger than the last, and the quiet time between bursts getting steadily larger as well. So let's take a look at solar cycle 25, and it seems to be showing the same sort of pattern, although the bursts seem to be slightly closer together. We've had 3 bursts, and we've just finished the 3rd burst, so there should be another burst probably in the next few months. This is a plot of the number of sunspot regions as a function of time. The red dashed line indicates the solar minimum period, December of 2019. Blue indicates sunspot groups that have the polarity associated with solar cycle 24. And you see they don't die out immediately after solar minimum. They go on for a while, but they seem to have pretty much died out now. The orange indicate regions from solar cycle 25, and yes, indeed, they started before solar minimum and are building very steadily, indicated by the dotted line going up to the right. This last month, August had the most new cycle regions so far this cycle at a number of 30. But many were small ones that didn't last very long or weren't large enough to merit any interest by the professional community. Only 13 of them, 43%, were large enough to be numbered by NOAA. So let's see if we can make a prediction about how many sunspot regions we're going to see so far this year. At the moment, we're at just over 170. Projecting forward at this rate, we should reach about 260 regions by the end of the year, which will be twice as many regions as we had last year. So it looks as though the solar cycle is continuing to accelerate. You can measure a solar cycle's progression by a number of different parameters. Obviously, there's sunspot number. This is the last two solar cycles, monthly sunspot numbers. The purple plot here is the NOAA and NASA estimate of solar cycle 25, which is about 10% larger than solar cycle 24. The red and the orange are the two models I talked to before, but you can see all of them, the actual data and those two models, are outperforming the NOAA and NASA model. So it would imply that we're going to have a larger solar cycle than NASA or NOAA predicted. We can look at the 10.7 centimeter radio flux, and that too is outperforming the model that was predicted. Number of spotless days, well, we compare like with like, and 2009 had more spotless days, so it was less active than 2020. The equivalent time for the next year, 2021, was 2010, and already we've had a few more spotless days than that, but not significantly so. But it would say from now on the number of spotless days is going to get fewer and fewer as the sunspot cycle continues. And then we can also look at geomagnetic events. And you can see we have about an equivalent number of geomagnetic storms at the beginning of solar cycle 25 compared with the beginning of solar cycle 24. So that's pretty much a push. Okay, let's take a look at active region 2860. It emerged on the 24th of August near the southeast limb. It developed into a major region, i.e. one greater than 250 millionths of the sun's surface area. And I'm going to show you a video of that development now. It produced an M flare on the 28th of August. It's the only M flare so far from this month. And I'm going to show you a video of that taken in the Solar Dynamics Observatory AIA 94 angstrom channel. Here is the light curve of that flare. As you can see, it was an M4.79 event. And that would put it in the category of an R1 radio blackout event, which is a relatively mild such event. It's going to rotate off the sun in the next couple of days. Actually, it's just about off the sun now. But it's likely to be large enough to survive and return sometime like the 18th or 20th of September. So that's something to look forward to, though I doubt it will be very active by that time. It will have finished growing. So what about the flares for the rest of the time? We had 45 flares, including one M flare, but 80% of those were from active region 2860. The color code here is after solar minimum, the red dashed line. Dark green is solar cycle 25 C flares. Yellow is solar cycle 25 M flares, and red is solar cycle 25 X flares. And you can see that we've had just the one X flare that was last month. We had one C flare in July, and we've already had a few C flares from the sun in September. So that looks as though this trend is going to continue. Without HelioViewer, I'm not able to show you very much about CMEs, but in the catalogue of CME events, 50 were noted by the LASCO coronagraph. That was fewer than previous month, which had 75. And I do have a video of the CME associated with the M flare. Well, we've had two geomagnetic storms this last month. Both of them were small G1 events. This first one occurred on August 2nd. You can see it just for 1 3-hour period went to a G1 event. Then we had a second one on the 28th of August, also a G1. And here is the geospace data from the Discover mission, which I had a great deal to do with building. You can see the most important thing here is the magnetic field, particularly the BZ component, that's the red on here. And you can see on August 2nd, it went slightly negative. That was the first of those geomagnetic events. And on the 28th, it went quite strongly negative, and that was the second of those geomagnetic events. Otherwise, it was relatively quiet through the whole of the month. We had fairly low proton densities, about 30 or less per cubic centimeter. The speed was relatively modest, going only up to about 500 kilometers per second. And the temperature was relatively low, hovering around 10 to the 5th degrees Kelvin. We keep hearing a lot about the fact that cosmic rays are at record highs and all the rest of that. This is just plain not true. Here's a plot of the cosmic rays over the last few years. You can see at solar maximum back in 2014, the cosmic ray flux was quite low because the magnetic field of the sun was strong. As the solar cycle went on, the magnetic field weakened and allowed more cosmic rays in until solar minimum occurred. Since then, the cosmic ray flux has started to decline again as the new cycle has grown. So what conclusions can we draw from this? We're only 20 months into solar cycle 25, and we're getting healthy numbers for the sunspots, flares, and CMEs. The average rise time for a solar cycle is 4.4 years, anything as short as just over 3 years to nearly 7 years. So that means that the earliest that solar maximum will occur is mid-2023, and the latest is probably 2027. We can expect quiet times for the next few weeks, and then another bigger burst of activity in the October to December time frame. Stay well, stay safe, and goodbye until next time.